think it's better to start now. We already took 5 minutes. So let's start with the basics of coding. And I'm sure most of you are working on your research and you're familiar with most of the things, but some of the components of data management are not usually covered in our basic courses. So probably the thing that we're going to pick from this is some of the principles, not just the coding and how to do the analysis. So let's start with a plain document of SPSS, and let's see how to do some of the new codings. So here I have a plain SPSS document. So if I might have different variables. So when I start coding, I should identify what my variables are, how to code them. So let's say we're doing a research on COVID-19 and we have collected information on COVID-19 disease severity and other socio-demographic and clinical factors. So the first variable that I want to take information on is age. So if you remember last time we said, if we have a variable, a continuous variable, a numeric variable, the best way to do is to collect the information as it is. We don't ask an individual if their age ranges, if their age lies in a range from this to that. Rather, we just ask them, how old are you? And we write the number. And later during the data analysis, we transform it into a coded, a classified range of values. That's the proper way to do. And this works for every numeric variable, like weight, height, the BMI, their income, their laboratory values, and every numeric variable has to be collected in its natural form as it is, and then it should be classified later. So if I have age, when I write the age and just click enter, all other columns will be automatically coded as the default. Age is a numeric variable, so it's on the default, it's numeric, we're not going to touch it. The width is how many digits do you want to allow for this variable? So 8, we might not need 8. I mean, I bet we have 100 years old patient. I don't believe we have more than that, so we can allow 3 digits. And decimal, if we want to take age, if we're dealing with a pediatric group of participants, it would be good to have decimal places so that we can allow them to enter the month as a decimal place. But for adults, if we don't want to have decimal places, if we are going to ask their age in complete years, it would be great to avoid the decimal places and just put 0. This also serves as restricting these values will also serve as a data controlling mechanism. Normally, we use epinfo because it can control when there are error entries and others. So on SPSS as well, we can give it some sort of restriction so that the data, when we enter a wrong data, it will pick it. So if I have if by mistake I enter 4,000 for age, then it will automatically reject it because I have restricted the width to 3. And if we are sure that we don't have any patient 100 and above, we can restrict it to width of 2. So label is a place where we can explain the name that we entered. So normally age might not be something difficult to remember, but I can label it like this: age of the participant, incomplete years. Sorry. Age of the participant, incomplete years. Sometimes on the name column, we can't use spaces or we can't write long things. So it's just a code for us to remember the variable. We can't write everything. So sometimes, for example, for hypertension or for DM, I might use something like this. This is the code that I want to see during the analysis, but during your presentation, you have to use the proper form of the variable name. So I can write it like this: type 2 diabetes mellitus. So sometimes if we're dealing with a bunch of variables, like thousands of variables, like for example, in the EHS data, we have to make sure that we understand all the codes. So that the purpose of the label is to understand that. Don't forget that part. And so for age, after we enter the name, we label it as numeric. Numeric is the default actually for every variable that you enter. The default is the type is numeric, the width is 8, and the decimal place is 2. But after that, we have to arrange it the way we want. Values are labels that we give for categorical variables. Since this is a numeric variable, we don't want to code it, so there's nothing to code, we remove it. And let's forget the others for now. So the second variable that I want to take information on is their gender. So I say sex. Again, the defaults are here, like the numeric, width of 8, and decimal place of 2. We don't need that since this is a numeric, a categorical variable. We have to shift it from numeric to string. When you click on the 3 dots next to the numeric box, this option appears, and string is to mean that the variable is categorical, so we pick string. Then the width, if we pick a string, that means we're planning on coding gender as 1 and 2 or 0 and 1 for male and female. So our width is going to be just only 1 digit. We're not going to have more than 1 digit. So we have to stick to that, and we're not going to have decimal places. So we have to make sure that it is 0 as well. And here we can say sex of the participant. And values, we need values for this because it's a categorical variable. So now we started our coding. Our option is either we can give it a 0 for email and 1 for male. So if you want to see the details of the code, you can click through the 3 dots next to the box, and you can see what the codes are. So I can either code it as 0 and 1, or if later I want to code it as 1 and 2, I can change it into 1 and 2. So this is how we code a categorical variable. And for example, if we have a long, more than 2 responses, like COVID-19, COVID severity, for example, since the name doesn't accept spaces and other hyphens, the only thing you can use as a space is the underscore sign, so that you can separate your variables and it becomes clear to read. So here you can give it like 1 is asymptomatic, 2 is mild, 3 is moderate, 4 is severe, 5 is critical. So we can code we can give as many labels as we want based on the nature of the variable. So this is basically how you just code on SPSS. It's not difficult. So let's see on an already coded data set that I have, so that we can do the remaining things. You can see the screen, right? Last time we have seen the basic principles of coding, a very important tips. The first one is, if you remember, is to give it a unique code so that each and every entry can later be traced and identified, so that if there is a missing data or if there's a need for further digging, we can easily pick which patient or which participant is that particular entry belongs to. So MRN is a very important means of tracking your data. So you have to make sure to give MRN or any other unique code for, to track your patients, your participants. Next, I have these variables: age. I have age, sex, COVID severity, hypertension, DM, symptoms, and all of these variables. So let's make it simple. And for now, since I'm studying on COVID patients, I wanted to make my outcome variable the disease outcome itself, which is coded as 1 for day, 2 for alive. So I want to study if at the end of the treatment, if COVID patients recover or die. So that's what I want to study. So I'm going to make the outcome variable my dependent or outcome variable, and I'll use the other variables as my exposure variables. So let's see if the codings are the codings make sense or are correct based on the principle. So for gender, it's coded as 1 male, female, 2 male. I guess this is gender, and anybody can use any sort of coding. It doesn't have any hierarchy. Someone might say that it's better to code 1 as male and 2 female. You can also do that, and you can also do the 0-1 coding instead of the 1-2 coding. That's all right. And the other is for COVID severity, we have mild, moderate, and severe. And for hypertension, we have no, yes, and unknown. And the same for DM, we have no, yes, and unknown. So what the first important thing to check is we have to have consistency in coding. Consistency in coding is when we later interpret our result, we want our result to make more meaning and to be more presentable to the audience. So if I want to make my reference category, those categories where there is no symptom, where there is no disease, where the COVID presentation is mild, then I have to make sure that I have to make sure to give these codes similar or consistent coding. For example, as you can see roughly from this value, the no's are coded as 1, right? The no's are coded as 1 in all of them. Hypertension, no, is 1, 2 is yes. The same is for DM, and the same is for all other symptom categories. But if someone codes it like this, for example, 0 is yes, 0 yes, or we can make it like this. If someone flips the code, then I'll show you the problem. All other variables are coded as no, for is given the smallest code, but here on CAF we gave it on CAF we gave yes the smallest code. I'll show you what the problem is later. It's okay, anybody can use any sort of coding that's convenient for the researcher, but during analysis we might face some challenge. So it's more of a preventive action to make our analysis a little bit easier and more convenient so that we can save time and we don't make silly mistakes. So we'll get back to that later. So for now, the first one is making sure that your code are like functionally analyzable groups. So for example, for symptom, I have, it says mark the symptoms that you have. So here we have how many symptoms? We have fever, cough, chest pain, shortness of breath. So if originally any research question or tool is designed to have to be like this, like mark the symptoms that you have, then on there will be like a list of symptoms from which the patient can mark on. And what we normally expect is for the variable to be coded like this: 1, fever, 2 cough, 3 chest pain, 4 shortness of breath, right? So this is, which one do you prefer? So we can have only one variable that contains all the responses, like 1 fever, 2 cough, 3 chest pain, 4 shortness of breath, or we can have 4 different variables for the symptoms themselves, and which are labeled as no and yes. So which one do you prefer? Do you prefer, let's say, the first one, method A, just coding it as symptom and labeling all the symptoms as a response, or having all the response categories, the symptoms themselves, as a variable and coding them as yes and no? Which one do you prefer? Which one do you prefer? Please write your answer on the box. Method B, Emmanuel, thank you. Okay. I want to make sure you understand what I'm trying to say. So, okay. Okay. Method B, okay. Anybody, any different opinion? Is there anyone who would say yeah would say method A? Okay, great. Thank you. I think most of you agree that method B is preferable. Why? For example, if our patient has fever, then great. So if our patient has fever, anybody who prefers method A, let's see what the problem is going to be. Here, if anybody has for the symptom, if you can see this, right? So this patient, the first patient has only, as you can see, only cough. So for this patient, entering the code 2 will be easy, cough, because the patient has only cough. Let's go down, and here, the patient on the 11th row has 3 symptoms, has cough, chest pain, and shortness of breath. So for this patient, what we have, our option is either to go back and give a 5th code that says cough, chest pain, and shortness of breath. And if we keep doing this, how many combinations are we going to have for the 4 symptoms? Eventually, we are going to face the problem of a very small frequency in our analysis that we don't want to use for regression, and our data will be useless. So if you have symptom categories or comorbidities or any other responses which need a separate coding, make sure to code them separately so that we don't face such kind of problem. So this type of coding is wrong, and I have to make sure to remove this type of variable. The same works for comorbidity. Here I have hypertension and DM separately coded instead of one big comorbidity question with a list of labels that contain hypertension, DM, cardiac, and others. So the first principle is this one. Make sure to follow that. The other is consistent coding, and we will see that during analysis. The other is reference category. When we pick the reference category, it's always preferable to use the smallest category. I know I haven't covered analysis yet, but just follow what I am doing, and let me show you what the problem of inconsistent coding and using a reference category as the largest category. So let's say my outcome is, my dependent variable that I picked is outcome of COVID-19, which is coded as 1 day to alive. So I want to code this properly. I'm sorry, I was reading the text. Someone from AMA might check the boxes and let me know if there's anything that I should respond to, since state is not available. I'm switching between the screens. So my outcome is categorical with 2 responses, dead and alive. So the proper regression model, let's say this is a cross-sectional or case control design, and the proper regression model that I have to use is binary logistic regression. So let's run binary logistic regression, and let me show you the coding problems. So here, this is my outcome. Let's say I have gone through all the proper steps of regression analysis, and finally, what I want to analyze is SEGs, COVID severity, hypertension, cough, shortness of breath. These are enough for now. So let's say these are the variables that I want to analyze. So for the categorical variables, what we are going to get is on the way. We can use this as well, age as well. So here we have different options on the boxes. As you can see, the first one is, it says categorical. This is a box where you can pick which reference category you want to use for your analysis. Hypertension is also categorical, so we have to enter it here. So normally, when we interpret our results, it is going to be like, for example, the odds ratio that I'm going to get is going to be, maybe for you to make more sense, let me show you, let me run the result first, and let me show you that. So this is the output for the regression that I just run. And as you can see, let's pick for example, sex. For sex, in bracket, it says 1. And the exponent shape B that we have here is 0.530, which is the odds ratio. We'll see it some other time during analysis. So 0.530 is the exponentiate p-value, or the odds ratio that we get for sex, and this is outcome, which is coded as which is labeled as the death and alive. So this is only one result. That means the result that we get is either for male or for female. So if it is for a male, this number is going to be like the odds of dying from COVID-19 among males is 0.53 times lower compared to females. But if it is for females, then it has to be, the result is going to be read as the odds of dying from COVID-19 is 0.53 times lower among females as compared to males. So the result that we get is only for one of the categories. So which one is it? The question is, which one is it? The SPSS has a default, which one is it first? I want to know if there's anything that, if you have any opinion, for which result, for which gender do you think is the result that we get, the 0.530? We just run the analysis on SPSS. We run a binary logistic regression analysis, and we have two groups, female and male. So what, for which group is that result? For which group do you think is that result? Female, okay. Female, okay, great. Why female? Female, why female? Female, I see female. Okay, if we agree on, yeah, male is the reference group, great. So the result is for female. So why is great? UCS, the default in SPSS is last group as a reference, great. So SPSS, by default, it uses the last group of the independent variables as a reference. So if without touching any of the boxes, without changing any of the reference categories, if you run the analysis, the result that you get is for the first category as compared with the last one. It will make the last category the reference variable. So in this case, that since you have three responses here for COVID severity, the result that you are going to get is going to be 3. 2, the first one is mild as compared to severe. The second one is moderate as compared to severe. So it will make severe the reference category. And if you check the symptoms, the reference category will be the last one, no. So what I meant by consistency is, I mean, are you comfortable with using the last reference category as reference? Would you prefer to use the first category as a reference or the last? Let me show you. For example, here, for DM, I have no, yes, and unknown. So for the results that I get for DM, my reference category is unknown. So if somebody presents to you a result that says patients with diabetes are 2 times more likely to die from COVID-19 as compared to those whose diabetes status is not known. Does it make sense? Making unknown groups, other groups which are not properly identified, is not recommended. We're not supposed to use these groups as references, because these groups are, we don't even know anything about these groups. We're not sure if these unknown groups have diabetes or not. So we should spare this type of groups from being a reference category. Other groups, unknown groups, and other unidentified groups. So we don't want to use this as a reference category. So if our problem is only DM, if all other things are coded properly, and if we are comfortable with using the last reference category for others, what we can do is, let me show you here. We can separately change the codes for some of them. For example, we can go to the categorical box. So what we don't like from the regression is DM is coded as no, yes, and unknown, and the reference category, as you can see, is the last. The last is the reference category, the default is the last. So if I am comfortable with all other categories all other variables as a to use the reference of the last category, then, and my only problem is DM because the third response is unknown, then I can just select DM and click first and then change. So as you can see, all others are not changed except DM. On DM in brackets, it's changed the code into first, and it shows us that it's changed by writing the word first in a bracket at the end of the variable name. So we can do this, it's fine. But if you have like a number of variables, doing this every time you do your analysis is very difficult. Regression, you don't expect to run regression once and get your final answer. You will do this like 100 times for one study to make sure that you get the most credible result. You have to do your data management, you have to do reanalysis, you have to do recategorization. So you're going to run this thing like so many times. So every time you run this, do you really want to come back here and select few categories and make them first and leave the others to be last? I mean, personally, I would rather start by doing some preventive works, like making all the first reference categories as the more convenient categories, which I want to use as a reference. For example, I would prefer my COVID-19 severity score, severity level as mild to be my reference category. I mean, comparing patients with more severe disease with those with less severe diseases makes sense also clinically and for the audience. So I prefer to make my category the first one, mild. So I coded it as 1 mild and with increasing severity score, and I coded all other variables as no, yes, no, yes, so that my reference category will be no, where there is no disease, where there is no symptom. So when you interpret it, it will make sense. Patients who presented with cough as compared to patients who did not have cough, their odds of dying from COVID-19 was this times. So this is a more convenient way of presenting your results. So the best thing to do is, now we have a problem because all other variables are consistent except this one, except cough. Cough is coded as 1 yes, 2 no. So what do you suggest we do? So we want 1 to be no, 2 to be yes, but it's reverse coded here. So instead of instead of using it as it is and changing the code, the reference category for cough separately to make it consistent, what can we do? Write me your answers in the box. So here, if all of them are consistently coded, what we can do is we can select all and click first and change. So all of them become, all of the first category references become, all of the first responses become references for our result. So this is easy. If you have any number of variables, it's very easy. Like, let's say we have all of them in here. So what you can do is you can go here, you can select all and then change. So all of the categorical responses are changed to the first as their reference category. So how to make sure that is to see if there is the word first in bracket at the end of each variable. Sometimes just because you clicked first, that it doesn't change the reference category unless you click change. So you have to make sure you click change, and in addition to that, you have to see if there's the word first at the end of each variable. So since this is easy, what I prefer to do is to change this coding. So what do you suggest? Thank you. So we would rather change the code, right? So one of the techniques of changing a code is you can change it manually. If you're comfortable dealing with numbers on a computer, you can change it manually without losing the data in the codes. But the more objective way of changing it and without making mistakes is using the transformation command. So I can go to the transform and I can say recode into a different variable or recode into the same variable. Let me show you with a different variable. Recode into a different variable command is, it will keep the original variable that we want to record, and it will create a different variable where it has where there is where it's coded as the way we want it to be coded with the new codes. Recording to same variable is a command that will change the code of the original variable, and we will not get a different variable, rather it will change the code of this original variable. So let's start with the recording to different variable. What I want to record is calf. So it here it says on the output variable, what do you want the name of this new variable to be? So let's say calf, I can say calf2, and the label is calf with the new code. I can give it like this, or you can give it any name that you want. And we go to all the new values. So here, since our variable is a code, we're changing a code into another code. So what we're going to do is, here, this is a place for the first column is a place for to enter the old values, and the second column is a place to enter the new values, and this big box is the place where it shows us from which code to which code that we have changed our variables, so that we can confirm it. So here I have one is coded as yes. So I want, right, one is coded as yes. I want one to be 2, right? I'll say add, and I want 2, which is coded as no here. I want 2 to be 1. So I asked the command to change 1 into 2 and 2 into 1. So we'll say continue, we'll say okay. So it will show us on the output, on the SPSS output, that it has changed the code. So we have here the code. Since we don't have a label, we won't be able to get it. We're just going to get random like 2s and 1s because we haven't coded it yet. So we have to give it a label. 1 is no, 2 is yes. So now, as you can see, it's coded as yes and 0. To flip between the codes and the word responses, you can click this one on the tab above 1 and A. As you can see, when you click that, it will flip back between the codes and the responses. So as you can see here, the first response is 2. It should be yes now. Yes, it is yes. Here we have 1. It's no. So we have successfully recorded it. But we can also do another recording, which is, since we don't want to reserve the original variable. I mean, we're not interested in keeping the original variable for other purposes, so we can record it on the original variable. So recording to same variable. So when we record it on the same variable, what we can do is we'll remove outcome. Here we have history of calf. Since we don't have any, since we're not coding it into a different variable, we will not have that kind of box, the one that we entered the variable, a new variable name and others. Here we only have all the new values. So here I want 1 to be 2, and I want 2 to be 1. So I'll say add. We did the same thing as we did on the new variable. So here it's changed. Unless you change the values on your own through the transformation command, it doesn't change it. To see the change, we have to go here. Here we have no and yes. As you can see, no is oh, the problem with this one is, unless let me show you, it's already recoded. But since the label is the one that we already have, which is 1 is yes, 2 is no, it will not change unless we change it. So we have to come here and remove this. We have to change this as 1. And we have to add this as 2. Unless we change this, the transformation command has changed the variable, its frequency and everything has changed. But unless we change the label, what this command reads is the label that we gave it on the main tab. So unless we record it unless we change the label here, which the values here, which we can't do through the transformation command, our values will not change. So we have to make sure it's changed. So now yes is 2, as you can see, and here we have 1 is no. So transformation command is a very easy one, but it's important to do. And the other transformation that we want to do is, if you remember, one of the principles is when we code our dependent variable, it can be coded as 0, 1 or 1 and 2, that's fine. But if we have at some point, if we have to export our data into other softwares like Stata, R, especially Stata, if the smallest code of the outcome variable or the dependent variable is not 0, it doesn't analyze the data. So on SPSS, it's fine, but we don't know if at some point we might want to export our data on Stata and want to do further analysis. So it's always better to anticipate that kind of problem and code our variables properly. So I have to change this 1 and 2 code into 0 and 1 so that it will be ready and convenient for any software that we have to use in the future. So I have to make date 0 and alive 1. So we will follow the same command, recording to same variable. And when we record it, this is my outcome. It says all the new values has to be changed. You say yes. So my old value, 1 is date. I want it to be 0 now. And say add and alive, I want it to be 1 now. So the original variable, which is coded as 1 and 2, will be changed into 0 and 1. And now it will make more sense. So you'll see a very interesting thing. Now, since we didn't change the code, the transformation command has changed it. But since we didn't change the code, the result that we get is still like the original. 1 was coded as date, so we still have 1. But since we don't have any 2 codes, the remaining, let me show you by assorting it. See, here we have on 0, if you try to change it between the word and the code, you can't change it because on the original coding, there is no 0. We only have 1 and 2. Unless we change it, it can't read the 0 and it's misreading date as 1. But we have already recorded it into 2. So to solve this problem, we have to come here and finish the job by recording it as date is 0, change, alive is 1 now. So we have to change the code, the label here, so that it can match our transformed data. So date is 0 now and alive is 1, as you can see. So this is how you do transformation, but you have to be careful and you have to make sure to record your originally labeled variable. Unless you change the labels, the transformed data won't match your old coding. So you have to make sure to record it as well. So if you're not comfortable, it's always an option to change it, to record it into a different variable, and you can delete the original variable after you create the new variable that you're comfortable with. So both are options. You can see it again. So since we don't want this variable, I'm going to delete it. So one more thing is when we do transformation, transformation is not only done for a recording of a variable, but rather coding of a numeric variable. So here we have age. We definitely prefer to present age as a categorical variable rather than as a numeric variable. So how do we transform it? So we do the same thing, recording to a different variable. So here we had calf, we remove it and enter age. So what new name do you want to give the new variable? I prefer to call it age cat. And the label is age. Let's say if we want to code it by 10 years gap, age 10 years, category. So I have changed it. Oh, see, I have entered instead of an underscore, I have entered a hyphen and it didn't accept it because the name can only accept underscores and no space and no other characters. So I have to say, click all the new values. Here, we're not recording an already coded variable. Rather, we are coding a numerical variable into a code. So what we have to use is this command, the range system, that we have to use is the range system. So if we want to code it using a range of values, let's say if we expect the youngest age to be in their 20s, we can start by coding it as less than 30 or less than 29, and then with 10 years increasing age category. So let's start by coding it as less than 20. So it says range lowest true value means it will code all age groups 29 and below as one code. And what do you want that code to be? You can enter it in the new value. I can say 1. So it's saying all age groups 29 below will be coded as 1. So after that, we can enter like 32, 39 will be 2, 42, 49 will be 3, 50 to 59 will be 4. If you remember, we have to make sure that we enter mutually exclusive. We code our numeric variables into mutually exclusive and exhaustive categories so that one individual cannot be counted into different groups. That's why, as you can see, each group are separate and no single value lies in two groups. So you have to make sure that. And if I have very few patients 60 and above, I can group them together. So I'll pick the range value through highest. So value through highest means it will code all patients 60 years and above as 5. So I have coded it this way. I'll say continue. And okay. Here we have the new category. So we have to label it again. 1 is 20 and less. 2 is 30 to 39. 3 is 40 to 49. 4 is 50 to 59. 5 is 60 and above. So now we have created the transformed data and we have the results. You can flip between the codes and the labels like this. So coding numerical variables is also easy. So one final thing to do is to see if we have small frequencies. Small frequencies are the biggest problem in our data analysis. So we have to make sure if we have small codes or not. So the easiest thing to do is to run a frequency for every variable. So you can select all. Let's say for now we're interested in some of the variables up to here. Let's say these are our only variables and that we want to see these variables and age category. Since we want to use it in a categorical form, we have age. So we can run it just like this. After entering the variables into the box, you can say okay. And let me show you the output. You can see the output box, right? Okay, so we have here the output. It says the first one is aging category. We have the frequency. The frequency is the simple count of the number of participants in each group. So we have 195 patients under 30 years of age, and that constitutes 36.8% of the population. So you just scan through the percentage and see if there is a small distribution, if there is anything that's worth managing. So the most important thing to see is go through each and every boxes and see if there is less than 5% data in each category so that we can avoid that. So one data management principle is that. So age is okay. We don't have a small frequency. Gender is okay. They're comparable. COVID severity is also okay. It's a good proportion. Hypertension is good. Diabetes is good. Fever is also good. Here, chest pain. On chest pain, we have 0.2% summer, and this is only one patient, and it's coded as 5. So what do you think this is? what should we do? So we don't have 5 as a code. We did not enter 5 as a code for chest pain. We only have 1 no, 2 yes, and 3 unknown. So what do you suggest we do with this 5? What does it mean? We have 5 in the chest pain box, and this is a data entry error. So what should we do? Please inbox your answers. We have the same problem on shortness of breath. We have 3 and 4. For 2 individuals, we have 3 and 4 as an entry. So what does it mean and what should we do? Okay. Okay. This is an error, definitely, right? This is an error. So what the best we can do is we have to go back to the data, the raw data, and we have to pick where the advantage of coding it, the advantage of giving it a unique code is for this time. Let's say on cuff, we have, you can select the entire variable, and through a right click, you can easily do a sort ascending, descending, and we have the problems on chest pain. So let's do ascending, descending. See, when we sort it via descending command, we found our problem on shortness of breath as well. We have 4, here we have 5. So the problem is with the patient whose MRN is 28 and 2817. So we have to go to the card. If it's an electronic database, we can go to the chart. We can go to the electronic database and try to check if the data entry is, if we can get the proper answer. If we can't, what are we supposed to do? We can't categorize again because this is a coded data. It's not, we don't get it from categorization, rather this is a data entry error. So what we can do is we can't just simply correct it using a common sense. This is not something that we can correct using a common sense. We have to go back to the data. We have to see, and we have to try to get the original answer. If we can't get the answer, what we should do is we have to remove the variables and treat it as a missing value. Thank you. Somebody write as a missing value. Yes, since these are not very critical variables, I mean, our patient might miss a couple of symptoms through the data entry, but since these are not very critical variables, we can keep them and we can analyze it, but we have to make sure these entries are removed so that we don't have, it will be read as a missing value. So we can give it a missing value code, whichever is convenient for us. It can be like 99 or whatever. We can give it that kind of code, but it should not be analyzed. So the most important thing is to be able to identify if we have a missing, a data entry error, and correcting it. So we have here for the outcome, we have date is 19.1 and live is 80.2. We have total 99.2. We have missing values, which are 4. We have 4 missing values. So what do you suggest we do for these 4 missing values? It's an outcome. We have 4 missing values. What should we do? What do you suggest? Outcome, is it a very relevant variable? What do you suggest? Outcome, we have 4 missing values. We can go back to the data set and check which are the missing values. So for our outcome, here we have 4 missing values. So what do you suggest we do with this for patients? Should we keep it in the, should we analyze it? So what do you suggest we do? Any suggestion? Okay. Data imputation methods, does it work for every variable? Unless, yeah, the first thing to do for any missing values or missing values or error entries is to go back to the original data source and confirm and get the original data. But if we can't do that, if it's actually missing, what should we do? This is first we have to decide if it is a very important variable or not. If you can't have your outcome, you can't analyze the data, right? Outcome is a very important variable. Without it, we can't analyze our data for our patient. So the best method to do is, if we can't get the response for these variables, what we have to do is, we can't guess, right? We can't just, oh, it's all right, let's give it, let's label this patient as alive and let's give this one as dead. This is not proper. We can't do that. So what we have to do is, we shouldn't include these patients in the regression analysis. So we have to remove this entry so that we have a correct, credible data that we can analyze and get a credible result. So we have to remove it. That's one thing that we can do. The other is, surprisingly, we don't have a small frequency. Yes, re-entering the data. Yes, trying to get the original data and trying to re-enter the data. But if we can't do that, what we can do is removing it. The other is, one more thing. Yes, we have to remove the respondent, as we said. The other thing is, if we have numerical variables, we have to check for outliers. One more thing, outliers. We can check outliers using the explore command. We have age as a numeric variable, so outliers, we should check outliers only for numeric variables, not for categorical variables. So for numeric variables, we normally this is how you get it. The normal box is like this. Since we don't want the other plots, we have to remove the stem and leaf from it and dependents together for this one, and we don't need the normality test. So we just make sure on the box below to pick to select the second one, dependents together, and say continue, and this is the result that you get. So the circles outside the upper and the lower margins are the outlier. So we don't have on the lower margin, we don't have any outlier, but on the upper margin, we have outliers. So most of our patients are within the age range of 1 or 2, 3 years, up to 80 something. So we only have few patients above 80 years of age. So we can count them like 1, 2, 3, 4, 5. The numbers associated with the circles are their MRN, like this patient is MRN number 52, this one is 93, this one is 490, 89, and 70. So we can go back and we can remove these outlier cases, not for the purpose of describing the data, for the purpose of presenting our characteristics of the patient, but rather for regression analysis. We have to make sure these participants' data is not considered for the regression analysis. Otherwise, it might cause an error or extreme values. So this is one way of checking our outliers. We can also do run a simple descriptive table for age, and we can scan through the range of values, but this is the more objective one, and I prefer to run this one. Yes, clean the data set. Always for whatever type of error that what we're supposed to do is to go back to the original data source and check the original data. If it's still not there, if it's a true error, then we have to deal with it using different ways of dealing with errors and missing values. So this is one thing we can do. Yeah, what to do with the outliers. So these outliers, when we present our result, the first part is to describe the patients, the study participants. So for description, we're not going to touch these values. We will describe it the way it is. We'll say there are patients outside the range of values that we have, like above 80 years, we have like 6 patients. But for regression analysis, we don't want to enter this value. So we have to delete these entire patient entries for the purpose of regression analysis, because it will cause a wide range of values, something that's not acceptable. We have here one example, by the way, for shortness of breath. As you can see here, we have unknown for, not unknown actually, we have 4 and 5. If you remember, when we ran shortness of breath, we did get 3 and 4 error entries. Since we did not clean this and run the regression, look what happened on the final analysis. See, the exponentiate B is like in millions, and it can't even run the confidence intervals because this is an extremely unacceptable value, a very large value, and it can't even run the confidence interval for the odds ratio, and it's simply 0, 0, and here it's just a dot. So when we have small frequencies and when we have data errors, when we have outliers, our analysis will end up with odds ratio or any measure of association, which is very large and unacceptable, and which is even not appropriate to interpret. So one other tip is when we're dealing with numeric variables, we will remove them only if we are planning to use them as numeric variables. But if we categorize them, as you can see, since we already categorized age group, and since we gave 60 and above just one code, we're fine. We're not supposed to remove these participants because they are already coded and included in the age group 60 and above. So here it's fine, but if we want to enter the numeric variable as it is in our regression analysis, it will cause some disturbance in the values that we get, like the one that happened for shortness of breath here. So we have to remove them. But otherwise, in a categorized variable, it's fine to have any sort of extreme values. I think this is it. There are other things as well, but if this gives you some sort of clue about what we discussed last week, you can practice the remaining. And you can also get details of data management on Medical Research Lounge group. You can check the data management part, which is pinned in the Telegram group. There are details with SPSS demonstration, and maybe you can check from that.